March 10, 2019. A modern Boeing 737 MAX 8 lifts off from Addis Ababa Bole International Airport, just before 8:40 a.m. It's a routine passenger flight bound for Nairobi, Kenya, carrying 157 souls, passengers from 35 countries. The skies are clear. The brand new jet disappears into the morning haze. But just 6 minutes later, it slams into the earth at over 700 miles per hour. There are no survivors. In its final moments, the aircraft pitched violently up and down. The pilot struggled with controls that wouldn't obey. And buried in the wreckage, clues that would ignite a global aviation crisis. This is the story of Ethiopian Airlines Flight 302. Ethiopian Airlines Flight 302 was operating a regularly scheduled international passenger service between Ethiopia's capital and Nairobi, Kenya. The aircraft involved was a Boeing 737 MAX 8, registration ETAVJ, delivered just 4 months earlier. It was among the most advanced narrow-body jets ever built. At the helm were Captain Yared Getachew, 29, with over 8,000 flight hours, and First Officer Ahmed Nur Mohammed, a younger but licensed pilot. They were cleared for takeoff at 8:38 a.m. local time from runway 07R. The aircraft began its ascent normally. Engines were stable. Airspeed indicators matched. The initial climb looked textbook. But just 44 seconds after takeoff, something critical happened, unnoticed by the flight crew. The left angle of attack, AOA, sensor, a small vein that measures airflow over the wing, was damaged, likely by a bird strike. That single sensor began feeding incorrect data to the aircraft's flight computer. The 737 MAX featured a controversial new flight control logic known as MCAS, the Maneuvering Characteristics Augmentation System. It was designed to push the aircraft's nose downward in certain high-angle climbs to avoid aerodynamic stall. Crucially, MCAS relied on a single AOA sensor. Now, that damaged sensor began sending erroneous high-angle of attack readings, falsely indicating the aircraft was climbing steeply, when it wasn't. For the next minute, the crew followed their climb checklist. They retracted the landing gear and flaps as usual. But as the flaps came up, MCAS quietly armed in the background, misled by the faulty sensor input. Then, at 1 minute 6 seconds into flight, MCAS activated for the first time. Without any warning, the system trimmed the aircraft's horizontal stabilizer, pushing the nose down. The pilots responded instantly. They pulled back on the yoke and used their thumb switches to counteract the automatic trim. For a moment, they were successful. The aircraft leveled again. But 5 seconds later, MCAS activated again. And again, the nose pushed down. The crew continued to fight the automation, manually trimming against it. A tug-of-war had begun, between human pilots and an algorithm they were never properly trained on. In just 2 minutes, Ethiopian 302 was descending erratically, even as its engines remained at full takeoff power. Warning chimes, stick shaker alerts, and cockpit confusion followed. By now, air traffic controllers noticed a sharp and erratic flight path. On radar, the aircraft began to look unstable. Inside the cockpit, the pilots were battling to keep the jet level. And still, they had no idea what was causing the control surfaces to betray them. Flight ET-302 was only 3 minutes airborne. And the worst was yet to come. Ethiopian Airlines Flight 302 is climbing through 9,000 feet. It should be a smooth ascent into the thin, blue air above Addis Ababa. But inside the cockpit, chaos is unfolding. The aircraft's nose has pitched down twice already, each time triggered by MCAS, an automated system few airline pilots were even aware existed. The faulty left angle of attack sensor continues feeding false data into the aircraft's flight control computer. As far as the computer is concerned, the aircraft is in danger of stalling. In reality, it's not. For the third time in 30 seconds, MCAS activates, trimming the horizontal stabilizer down, forcing the nose lower. The pilots, once again, counter it with their electric trim switch. But they're fighting an enemy they cannot see. And then, they make a critical decision. At 2 minutes 43 seconds, the crew follows Boeing's emergency procedure for what appears to be runaway stabilizer trim. They cut power to the electric trim motors, switching off 2 stabilizer trim cutout switches located between their seats. With the electric system disabled, MCAS can no longer move the stabilizer. The aircraft is temporarily stable. But so are the pilot's own electric controls. They've eliminated the threat, but also their ability to correct it easily. Now they try to adjust the trim manually, using a wheel located on the side of the pedestal. But the forces on the aircraft are already immense. The plane is flying at nearly 375 knots, well above safe manual trim speeds. The stabilizer jack screw is under too much aerodynamic load. The manual trim wheel won't budge. They are trapped, unable to correct the nose-down pitch manually, and unwilling to restore power to the electric trim. In desperation, the captain instructs the reinstatement of the electric trim system, restoring MCAS, unaware that doing so will rearm the very system that forced the nose down in the first place. It is now 5 minutes 33 seconds after takeoff. Just 3 seconds later, MCAS activates again. This time, the trim moves to maximum nose down. The stabilizer forces the nose of the aircraft sharply downward. The control column vibrates. The stick shaker sounds. Altitude is dropping fast. The captain pulls hard on the yoke. The co-pilot radios ATC, brake brake, requesting to return to home. But his voice is distorted. The aircraft is descending rapidly. Vertical speed exceeds 33,000 feet per minute. That's nearly 560 feet per second, a near freefall. They are just 13 kilometers from the airport. But the terrain is rising. Ground proximity warnings blare through the cockpit. The pilots try to pull the nose up, but it's too late. At 8:43 and 45 seconds AM, just 6 minutes and 28 seconds after takeoff, Flight 302 slams into a field near the town of Bishoftu. The aircraft hits the ground at nearly 700 miles per hour in a nose-down, left bank attitude. The impact creates a crater 10 meters deep. The force is so severe that parts of the aircraft are driven straight into the earth. There are no survivors. All 157 people on board, passengers, crew, families, aid workers, students, are gone in an instant. And so ends the flight of ET-302. But the investigation is only beginning. The crash site is a scene of total devastation. A gaping crater, blackened soil, and scorched metal mark the final seconds of Flight 302. Recovery teams comb the impact zone, finding personal belongings, shattered components, and charred debris spread over hundreds of meters. Most of the wreckage is embedded deep into the Ethiopian earth. There are no large fuselage pieces. The violence of the impact has left investigators with fragments and questions. But amidst the wreckage, 2 critical pieces survive. The cockpit voice recorder, CVR, and the flight data recorder, FDR, the aircraft's black boxes, are recovered just hours after the crash. Visibly damaged, they are sent to BEA, the French Bureau of Inquiry and Analysis, for decoding. Back in Addis Ababa, grief is turning to scrutiny. This is not an isolated tragedy. Just 5 months earlier, another 737 MAX crashed off the coast of Indonesia. That flight, Lion Air 610, also went down shortly after takeoff. It too showed signs of unstable trim and pitch-down events. And it too involved MCAS. Now, investigators begin to compare the two. The flight data recorder tells a chilling story. In both crashes, MCAS activated multiple times in response to erroneous high angle of attack readings. In both, the system was triggered by a single faulty AOA sensor. And in both, the pilots tried, and failed, to override the automated nose-down inputs. The cockpit voice recorder adds emotional depth to the data. The captain and first officer on ET-302 are heard calling out procedures, coordinating their trim controls, and struggling to maintain control. There is no panic, only confusion, effort, and escalating urgency. They never mention MCAS, because they weren't trained on it. The manual Boeing provided to airlines made no reference to the system by name. It was designed to operate silently in the background. Even simulator training never exposed crews to MCAS-induced trim scenarios. Now, the industry is forced to reckon with a truth: the pilots didn't fail the aircraft failed the pilots. Boeing believed MCAS would never activate under normal flight. The assumption, that AOA sensors were reliable. That pilots would instinctively know how to disable it. That it didn't need full disclosure in pilot training. These assumptions were wrong. In just 5 months, they contributed to 2 catastrophic crashes, claiming 346 lives. By the time Flight 302 crashed, regulators were already beginning to question the MAX safety. But the second disaster sealed its fate. Just 2 days after the Ethiopian crash, China grounded all 737 MAX aircraft. Within a week, aviation authorities worldwide followed. And within a month, Boeing, the most trusted name in aviation, was in freefall. The crash of Ethiopian Airlines Flight 302 marked the second fatal disaster involving a Boeing 737 MAX in just 5 months. Together with Lion Air Flight 610, the 2 crashes exposed not just a flaw in engineering, but a deeper collapse of oversight, accountability, and trust in the aviation industry. Within hours of the second crash, aviation authorities around the world acted swiftly. China became the first country to ground the entire 737 MAX fleet. Within days, Europe followed. Canada soon joined. On March 13, 2019, under mounting pressure and against initial resistance, the United States grounded the 737 MAX, a stunning move, considering Boeing's political and industrial stature in the country. For Boeing, this was the beginning of a corporate crisis unlike anything in its century-long history. Inside Boeing, shock turned to damage control. The company had invested billions in the 737 MAX program. It was their fastest-selling aircraft in history, with over 4,500 orders on the books. Grounding the fleet meant halted deliveries, cancelled contracts, and a rising tide of lawsuits. But the true cost was measured not in dollars, but in confidence. Investigations revealed that Boeing never told airlines or pilots about MCAS. The system was added quietly, to preserve common certification with older 737 models, saving carriers from having to retrain crews. Even more alarming, Boeing pushed to minimize FAA oversight. Using a policy called delegated authority, many of the MAX safety assessments were approved by Boeing engineers acting on the FAA's behalf. This included the MCAS risk assessment, which failed to consider what would happen if the system activated repeatedly, or based on bad sensor data. Internal emails surfaced, showing Boeing employees mocking regulators, boasting about deceiving airline customers, and calling the MAX certification process a joke. In the wake of the second crash, U.S. Congress launched hearings. The families of victims, mothers, fathers, siblings, testified tearfully in packed chambers. Executives from Boeing, and officials from the FAA, were called to account. Under oath, the veil was lifted on a culture of cost-cutting, internal pressure, and a flawed safety certification model. The FAA came under intense fire. Once considered the gold standard of aviation safety, it had become too cozy with the manufacturers it was meant to regulate. Boeing's CEO was eventually forced to resign. And the MAX, once Boeing's shining hope, became a symbol of how engineering arrogance, corporate profit, and regulatory failure can collide with tragic results. The repercussions rippled across the industry. Airlines that relied on the MAX faced months, even years, of lost service. Countries reviewed their own aviation authorities. Pilots demanded more control over flight automation. The entire world began asking hard questions about the role of automation in modern aviation, about the limits of software, and the value of a well-trained human pilot. Boeing's losses mounted into the billions. But for the families of the 346 victims, no sum could restore what was lost. At crash sites in Indonesia and Ethiopia, memorials were erected, engraved with names, flowers, and the haunting silence of lives taken too soon. In the shadow of loss, the world looked inward. 2 crashes. 346 lives lost. Countless more altered. The events surrounding Ethiopian Airlines Flight 302 exposed a fragile truth, that trust in the safety of air travel, built over decades, can be undone by a few overlooked lines of code, and a system too willing to look the other way. But from the ashes of tragedy came change. In the months following the grounding of the Boeing 737 MAX, aviation authorities worldwide conducted independent reviews of aircraft certification systems. For the first time in decades, the United States Federal Aviation Administration, once considered the gold standard, was no longer the final word. Regulators in Europe, Canada, China, and Brazil independently certified the MAX return to service, each demanding changes, each raising questions. The FAA, under public and legislative pressure, acknowledged its shortcomings. The rules governing manufacturer self-certification, once an industry norm, were overhauled. Delegated authority was scaled back. Transparency, redundancy, and pilot input were elevated to priority status. One of the most painful realizations of the Flight 302 investigation was the gap between what pilots were told, and what they needed to know. MCAS, a system capable of overriding pilot input, was never mentioned in manuals, never covered in simulator training, and never expected to fail. When it did, pilots were left to fight an invisible enemy, with no playbook. That has changed. Today, every 737 MAX pilot must undergo simulator training that includes MCAS malfunction scenarios, runaway stabilizer drills, and high workload recognition. Training has been adapted to emphasize situational awareness, not just procedural memory. Because automation may support the cockpit, but it should never replace the human at the controls. Boeing's reputation suffered immensely. Beyond the billions lost in grounding, lawsuits, and cancelled orders, the company became a case study in what happens when profit outpaces safety. In 2021, Boeing agreed to pay over $2.5 billion in penalties and compensation, admitting that employees had misled the FAA about MCAS during the aircraft certification. But for the families of the victims, no settlement, no apology, no redesign could ever fill the silence left by their loved ones. Organizations like the Ethiopian Airlines Flight 302 Families Association continue to press for justice, not only for remembrance, but to prevent such disasters from ever happening again. Ethiopian Airlines Flight 302 departed Addis Ababa just after sunrise. It was supposed to be a short hop to Nairobi, an ordinary flight in an extraordinary aircraft. But in 6 minutes, the flaws of design, the silence of oversight, and the weight of assumption converged in a single fatal descent. And yet, from that fall, rose a new standard. One paid for with heartbreak. And written into the sky.